one way or the other, as well as buying yourself extra enrichment. But they are kind of holding on to, you can't straighten out the zone. A doesn't keep on going either up or out. It's still down. Okay, so interventions for enrichment. Herzog basically argued that there's three kind of components to the enrichment intervention. One is, what's the initial boost that you get? Both because it's interesting in and of itself, and our starting place in this whole line was thinking that there was nothing you could do about it, because remember, the biology, which also turned out to be wrong, was you're losing scads of neurons all the time, and so there's no way that intervention is going to be able to counteract the effects of massive brain loss with normal developmental aging. Another question is, you do this intervention, does it last? One of the things we saw a few weeks ago was that for simple memory interventions, most of the time the answer was actually no. It doesn't last, and even though people remember the mnemonic strategy, they don't actually use it. And then the other element, and the one that's been harder for the intellectual enrichment literature, has been generalizability and other cognitive skills. Can you get beyond just sort of teaching the test to older adults? So what they describe as the first generation studies, this is Sherry Willis's work in the 80s and on into the 90s. In general, the conclusions were that you actually got substantial training gains in the practice test. So you can take things that older adults are doing badly on for both cohort-based reasons and developmental aging reasons. It's like spatial rotation and inferential reasoning. You teach people how to do it, and they do a whole lot better. You can bump them up by substantial amounts. But transfer to other tasks is essentially absent. You teach somebody to do spatial rotation, it doesn't improve their reasoning, vice versa. So it's not like, this would be particularly relevant if you were a very strong believer in a sort of like motivational hypothesis or a stereotype threat kind of hypothesis. Because you'd be saying, like, older adults are going along thinking, I can't do this, or thinking that trying isn't going to make a difference, and you show them that it can make a difference on one task, and they would say, oh, hell, I can do this stuff, and they do well on everything. That shouldn't work. Or if you thought that there was some more general skill or mental ability that was being learned, if you were training on any fluid intelligence task, should improve fluid intelligence itself, and all other fluid intelligence tasks should improve. But first generation, anyway, not happening. Big surprise for people, especially with all the stuff going on not so well in the memory task, is that with these kind of things, spatial rotation, inferential reasoning, so forth, the training gains were maintained up to several years. For a lot of reasons that we won't go into a lot actually in the class, people had thought that you might actually change the nature of the latent constructs here through training, and that really didn't happen.
What is that?
And there was this idea, and it still pops up from time to time, that one of the things that happens with aging is because your abilities were declining, that the latent structure of intelligence would be more unified in older adults than it is in younger adults, and therefore, like the training up specific abilities might push you out of that kind of overgeneralization. So, and that didn't happen. So you don't need to worry.
You know how it says here training gains are maintained after several years, but then when we were talking about cognitive enrichment, it said that there were no, that effects were not maintained, so these are contradictory things, if I'm understanding correctly. In the previous slide that you had, it said how long are effects maintained, and you said not long for simple interventions, but here it's saying, so am I misunderstanding something?
I didn't mean to say not long. I said that.
Well, this number, it is...
Memory was not maintained long.
Oh, memory.
But intellectual functioning is a different story.
Thank you.
Okay. And very limited results with the dementias.
Okay.
Either with people with mild cognitive impairment or a little further on than that. And these are the kind of effects they're talking about. This would have got clipped off as I copied it. This is effect sizes relative to controls. So this is the mean for controls. No change is here at 0. And 1 would be about a full standard deviation. Generally changes of around 0.25, 0.3 and up. It's pretty important. So, you know, the effect, and this is the, this is mentioned, so this is actually a slide from Salthouse. Based on the active cognitive training trials, nationwide trials, doing this kind of stuff, thousands of people in it. And Herzog had also mentioned these results in passing several times. So it'd be good for you guys to have access to the actual slides. So, speed training, immediate post-test, you've got like about 1.5 standard deviations, and even out to 2 years, you're still around 0.9 or so. Reasoning training on reasoning, you're getting about half a standard deviation. It's holding up pretty well over time. Memory training on memory, about 0.2 or so. And whatever they were doing here actually did work better than most of the more targeted lab-based kind of stuff. And this is, this is a control group, so you're not providing the training, nothing changes, nothing improves by staying in the study. You're not getting attention effects or anything. Second generation studies, they start testing the limits. So what they were doing the first generation is they were simply looking at, can you change older adults on these things? With the presumption, and I don't think it is a straw person hypothesis in this case. I think this is what the conventional wisdom as well as the thinking in most of the health sciences and social behavioral sciences were at that time, was that you wouldn't be able to change older adults. It was a remarkable finding that you could even short-term effects with older adults. But of course, as we've talked about before with memory and so forth, if you give the same training to young adults, they gain even more from it than the older adults do. And that in fact, practice and training over time gives you a near perfect separation of young adult and old adult functioning. I think the next slide demonstrates this. Not only older adults, you do improve with more and more sessions of training. This is words recalled. But the young adults with the same kind of training, do even better. And in fact, when you get out to the end here at 35 plus, this is like the whole distribution kind of thing. So you've got very little overlap. You do a line right there. You've got near perfect separation. And it leaves you this kind of, interesting policy question of, what would you do if you could control this? Would you want to if you could just train the older adults, you could get them pretty close to young adult performance. But you have to keep the young adults from doing the same training. It's like you're going to get like, video game-based cognitive training. You only sell it to people over 60. You can level things out. I mean, as a social engineering goal, it's not a bad idea. It's tricky to pull it off in our society. But if everybody gets it, if anything, you actually end up, after a lot of mass practice, the gap actually gets bigger with the more practice that those groups get.